So in the first video, I explained the introduction to set theory. In that video, I explained types of sets, operations on sets, and properties of operations on sets. Properties of operations. These things I have explained. Now, De Morgan's laws. De Morgan's laws. De Morgan's laws states like this. Suppose A and B are related to non-empty sets, then A and B are related to non-empty sets, then A union B complement is equal to A complement intersection B complement. I explained what is complement of a set. A intersection B complement is A complement union B complement. This is called De Morgan's laws. Now, how to prove this? How to prove these two De Morgan's laws? I already explained how to prove that two sets are equal. Suppose A and B are any two sets. How to prove that A is equivalent to B? There are two parts. First we prove that A is contained in B. Then we prove that B is contained in A. Then A is equal to B. How to prove that A is contained in B? Two sets are there here. This is A union B complement is one set. Right hand side is another set. These two are equal. For that, A union B complement is contained in this. A complement intersection B complement. Secondly, A complement intersection B complement is contained in A union B complement. Two parts are there. And also, to prove that A is contained in B, what you have to prove? We take any arbitrary element x belongs to A and we prove that x belongs to B. X belongs to A implies x belongs to B, then A is contained in B. This is the technique. So what you have to do now? To prove first one, let x belongs to A union B complement. What does this implies? You know the definition of complement. This implies x doesn't belongs to A union B. That is the definition of complement. X belongs to A union B complement means x doesn't belongs to A union B. This implies x doesn't belongs to A and x doesn't belongs to B. A union B means x is not in A, x is not in B. What does this implies? X belongs to A dash and x belongs to B dash. X doesn't belongs to A means x belongs to complement of A. Correct? Now, this implies x belongs to A dash and B dash. A dash and B dash. So, x belongs to A union B complement implies x belongs to A complement intersection B complement. What does this implies? A union B complement is contained in A complement intersection B complement. So this is simple here. First thing is take x belongs to A union B complement. What is the meaning of complement? X doesn't belongs to A union B. This implies x belongs to A and x belongs to B. Sorry, x doesn't belongs to A and x doesn't belongs to B. What do you mean by x belongs to doesn't belongs to A? X belongs to A dash. X belongs to B dash. And is there, therefore belongs to A complement intersection B complement. Therefore, A union B dash is contained in A dash intersection B dash. Now on the other hand, the other hand, let x belongs to A complement intersection B complement. Reverse way, we have to prove that A complement intersection B complement is contained in A union B complement. Suppose x belongs to A complement intersection B complement. What does this implies? X belongs to A complement and x belongs to B complement. This implies x doesn't belongs to A and x doesn't belongs to B. X belongs to A complement means x doesn't belongs to A. Similarly, x doesn't belongs to B. This implies x belongs to A union B complement, or x doesn't belongs to A, x doesn't belongs to B means x doesn't belongs to A union B complement. One minute, huh? X doesn't belongs to A, x doesn't belongs to B. This implies x doesn't belongs to A union B, correct? Doesn't belongs to A and also doesn't belongs to B. So x doesn't belongs to A union B. What does this implies? X belongs to A union B complement. Doesn't belongs to A union B means it belongs to A union B complement. See, we have started with x belongs to A complement intersection B complement. That implies x belongs to A union B complement. What does this implies? A complement intersection B complement is contained in A union B complement. Take this as 2. Say what is 1? A union B complement is contained in A complement intersection B complement. In 2, A complement intersection B complement is contained in A union B complement. From 1 and 2, we have the equality. Right here. From 1 and 2, A union B complement is equal to A complement intersection B complement. Correct? A union B complement is equal to A complement intersection B complement. This is called De Morgan's laws. This is De Morgan's laws for any two sets. But later we prove De Morgan's laws for family of sets. I explain what is family of sets later. This is De Morgan's laws for any two sets. Similarly, we can prove the second one. What is second one? Second is about intersection. Yes. A intersection B complement is equal to A complement union B complement. This is second one. How to prove this one? Again, we have to prove that A intersection B complement is contained in this, and right hand side A complement union B complement is contained in A intersection B complement. First we take x belongs to A intersection B complement. What does this implies? X doesn't belongs to A intersection B. Correct? We take x belongs to some arbitrary element belongs to left hand side. But what do you mean by complement? X doesn't belongs to A intersection B. By definition of intersection, x doesn't belongs to A and x doesn't belongs to B. What do you mean by intersection? X doesn't belongs to A intersection B means x doesn't belongs to A or x doesn't belongs to B, because intersection x doesn't belongs to A intersection B means x doesn't belongs to A or x doesn't belongs to B. What does this implies? X belongs to A dash or x belongs to b dash. This implies x belongs to a dash intersection a dash or which union b dash. Explain once again. Here x belongs to a intersection b dash. What does this implies? A intersection b complement means x doesn't belongs to a intersection b. This implies x doesn't belongs to a or x doesn't belongs to b. X doesn't belongs to a dash or doesn't belongs to b dash. X belongs to a intersection, a dash union b dash. Now this implies a intersection b complement is contained in a complement union b complement. Take this as 1. On the other hand, let x belongs to a complement union b complement. What does this implies? X belongs to a complement or x belongs to b complement, because union means or. This implies x doesn't belongs to a or x doesn't belongs to b. This implies x doesn't belongs to a intersection b, because or means intersection. This implies x belongs to a intersection b complement. So the second part, x belongs to a complement union b complement. What does this imply? X belongs to a complement or b complement, because union is or. X doesn't belongs to a, x doesn't belongs to b. X doesn't belongs to a intersection b, because or is there. X doesn't belongs to a intersection b means x belongs to a intersection b complement. So if x belongs to a complement union b complement, then x belongs to a intersection b complement. What does this imply? This implies a complement union b complement is contained in a intersection b complement. This is 2. What is 1? A intersection b complement is contained in a complement union b complement. 2. A complement union b complement is contained in a intersection b complement. Now from 1 and 2, what do you get? They are equal. From 1 and 2, A intersection B complement is A complement union B complement. Now, while going to this video, you cannot write down the notes. That's why we give the full notes of this topic in the PDF form. We will give it. Only you go through this video once or 2 times or 3 times, so that you can understand the concept. Then you will get the notes also. Next is relations. In set theory, what I explained is, from the examination point of view, or we teach what is there in your syllabus. In your syllabus, introduction to set theory is there, that I explained. Some basic properties of set operations, union, intersection, difference, and De Morgan's laws for 2 sets, A and B. Next, generalized De Morgan's laws is there, that is more important. Now, next is relations. Relations also, that this topic you are familiar with this topic, because you have studied in first year PUC as well as second PUC. You have studied what is a relation. Can anybody define what is a relation? Relation means in day-to-day lives, among human beings, we have different types of relations. Is a brother of, is a sister of, is a mother of. These are the different types of relations. In mathematics also we have different types of relations. Example is greater than, A is greater than B, B is equal to A. These are the relations. Or B is smaller than A. A is greater than B is same and B is smaller than A. Or A divides B. You know this one. A divides B. Or one more relation I give example. A is congruent to B modulo M. I think you are familiar with this relation also. A is congruent to B modulo M. When you say that A is congruent to B modulo M, if and only if M divides A minus B. Now these are some relations, but how do you define precisely what is a relation? E is greater than, E is less than, all are relations. But we have to define what is a relation. For that, you must understand first what is cross product of two sets. A cross B, cross product. Suppose A and B are any two non-empty sets, then see the definition, A cross B is set of all order pairs AB such that A belongs to A, B belongs to B. This is called cross product of two sets, Cartesian product of two sets, A cross B, two sets, A and B. A cross B is therefore defined as set of all order pairs AB, all order pairs AB such that A belongs to A, B belongs to B. This is A cross B. I give one example. Always, if we give example, then it will be more clear. Take A as set 1, 2, 3, B as AB. Then, what is A cross B? A cross B is set all order pairs 1A, 1B, 2A, 2B, 3A, 3B. This is A cross B. Now one more important result here. If A has m elements, B has n elements, then this set A cross B has mn elements. M into n elements. How many elements are there in A cross B? 1, 2, 3, 4, 5, 6. Here it has 3 elements, B has 2 elements, so A cross B has 6 elements. At the same time, what is B cross A? B cross A means A1, A2, A3, B1, B2, B3. This is about cross product of two sets. Now, we define what is the relation. I think all of you followed what is cross product of two sets. A and B are any two sets. Then A cross B is defined as set of all order pairs AB such that A belongs to A, B belongs to B. And I have provided one example also. Now, what is relation from set A to B? The subset of A cross B is called a relation from set A to B. Definition is quite simple. It is like this. The subset of A cross B is called a relation from A to B. You know what is A cross B? This is A cross B. It consists of mn elements. If A consists of m elements, B consists of n elements. A cross B consists of m into n elements. Now, if we take subset of that A cross B, that becomes a relation from A to B. Now, relation from one set to another. Now, we are interested in relation in a set. Relation in a set. What is relation in a set? It is a subset of A cross A. Suppose A is any non-empty set. Relation in a set is subset of A cross A. That is the definition. Now, I give example here for relation. Suppose A is non-empty set consisting of 1, 2, 3, 4. Then I define R1 is 1 2 1 3 1 4, and R2 is I take some subset of A cross A. How many elements are there in A cross A? 16 elements are there because 4 into 4. I have taken only one subset of A cross A. Second subset is I take like this 2 1 3 1 3 2 4 3, because it is subset of A cross A. I have taken some subset of A crosses. R3 is suppose 3 1 1 3 2 3. Now all these R1 R2 are their relations in a set A. Here you can easily understand what special or what is the specific relation here. Relation is less than here in first one. Is less than, because 1 and 2 means 1 is less than 2, 1 is less than 3, 1 is less than 4. Here is greater than 2 1 means 2 is greater than 1, 3 greater than 1, 3 greater than 2, 4 greater than 3. But what about third one? We cannot find out any specific relation here, but it is a relation in A because it is a subset of A cross A. 3 1 1 3 2 3. All these R1 R2 are their relations. So what is the relation? Relation in a set is it is a subset of A cross A. A cross A. This is the example. Now, in relations, there are special types. We consider this as special types of relations. Special types of relations. How to define the relation? Relation in a set is subset of A cross A. Now first one is types of relation. It is reflexive relation. First one. Second, symmetric relation. Third one, transitive relation. Transitive relation. There are mainly